There we go. All right, so if you have your books with you or if you have your packet out, I'm going to teach for about 30 minutes, maybe a little less, and do a couple of demonstrations, pretty neat ones, I think. And then we'll kind of wrap up everything in this chapter. It is the shortest chapter in the book. You spent all last week on it, so it's not like I had to spend another week on it. Didn't have to. And the next thing we'll do is I'll be showing you something that's not in the book after Monday's quiz. It's a kind of big quiz, so you might want to call it a big quiz. How about that? All right. So what I'm going to do is let's go through this, and I'm going to show you some things. And all I want you to do is, because the chapter is mainly there's about 15 words in this chapter. And as long as you understand how to use those words, I think you can understand this chapter pretty well. Let me go ahead and start this up. Let's go to start with page 56. Now, this is what I did on, Monday. On Monday, we went over the states of matter. Do you remember that? Solid, liquid, gas. We talked about who's compressible. So I understand you want to go home and say, I think I'll just memorize that chart. You can, but if you understand the chart, you don't have to memorize it. If you said, well, I know why solids have a definite volume, because they're held close together. They're so close together. You see that? That's why they have a definite shape. That's why they have a definite volume. That's why they're not compressible. There's no empty space between them. If you could do that, that's so much better than saying, I need to go memorize that chart. All right. Anyway, we did that twice. Let's go to the next page. I'll show you on page 58. Now, 58, this is where they do show you a change from solid, liquid, and gas. I actually don't like the example the author used in almost every case, except for water. In almost every case, except for water, the solids will always be closest together. The liquids will also be very, very close, and it's the gases that are really spread out. It just happens to be that water is a very unique thing, and when it's ice, it actually is a little bit less dense than liquid water. And so I don't like the idea the author should have used that as an example. If he had used gold, I would have seen gold really, really close as a solid. Then I would have seen gold really, really close as a liquid. And then I would have seen gold like that as a gas. So that's the only thing I didn't like about the person using it. Do you need a new mask? Sorry. I guess we gotta stay here. This one I'm going to do a little demonstration sort of like this one. This one right here would have cost the school about $150, and I would have used it about once a year, and I could have done that. It's a neat little apparatus. I actually have a mini version of it, and not this week, it's very busy this week, but next week, if you felt like, I would do that. I would do an extra credit project that dealt with an experiment, a little experiment. It takes about 1 hour. If you have about 1 hour of your time, maybe only 45 minutes, and you have your own 9-volt battery. If you bring your own 9-volt battery and you have 45 minutes of time, like I'll be here after school on Monday, I'll be here after school on Tuesday, maybe you can do it during lunch. If you'd like to, I'll let you do a little electrolysis experiment on your own. Okay? And that'd be for extra credit. Now, the picture you see in the book is the same one that a person did a couple of years ago as an extra credit project. Can everybody see that? So the word electrolysis, lysis in Latin means to split or destroy. And electrolysis means to use electricity to split or destroy. Now, why? And I'm going to do a little demonstration here, kind of like that. It's a cheap version of it, but it works. Why is this in this chapter? You know, not very often do teachers ask you, why do you think this picture, what does it have to do with this chapter? What do you think? You have an idea? Why do they want to show me electrolysis? And by the way, electrolysis is where water, by using electricity, will be split into oxygen gas and hydrogen gas. So why is it in this chapter? Yes, thank you. A little bit louder. Right. Now, how did you know it was a chemical change? That's a great answer. How did you know it was a chemical change? Yes, you are correct. It went from the substance called H2O into something new called oxygen gas and hydrogen gas. See that? That's why it's in this chapter. if you have a compound, if you have a compound, what is the only way you can separate the elements in a compound? What if I had C6H12O6? What is the only way I can separate those atoms? If it's in a compound, okay, the only way to separate them is a chemical reaction. I have to have a chemical change. Get it? But what about a mixture? What about a mixture? What if I have a mixture? Is a mixture the same thing as a compound? This is where you have to think, okay? This chapter is asking you to think a little bit. If you have salt and water, what did we find out yesterday? What can you do if you had salt and water? That's not a compound. That's a mixture, isn't it? See that? So how do you separate things in a mixture? Do I need a chemical reaction or not? What do you think? I'm just talking English. I'm just using English words. Okay? Do you think, we said it was a compound. The only way to separate the elements in a compound was what? What did we say? It was a chemical reaction, wasn't it? It had to be a chemical change. But how do you separate things that are in a mixture? It's a physical change. You get that? I don't need a chemical reaction. So if I filter that stuff there, and the sand stays in one place, and the salt or the water goes through it, then I separate them, and there was no chemical reaction. There was no chemical change. I start with sand and water. What do I end up with? Sand and water. There's nothing there. What about yesterday when you saw this right here? This picture, the next picture. What was this called? It wasn't a filtration apparatus. What was it called? Everybody, raise your hand if you know. It's not oops, I almost said it. It's not a filtration apparatus. What is it? Distillation. See that? Now distillation, if I have salt and water here, I can separate the salt and water. But wait, salt water is a mixture. And you can always separate a mixture by what? Do I need a chemical change, or can I do it by physical means? And that's one of the big things in this chapter. On the test, I have, I don't know, 6, 7, 8 questions just like that. You know, if you want to separate things in a mixture, you don't need a chemical change to happen. It's all physical means. So I started with salt and water. I ended with salt and water. That's why it can't be a chemical change, have it? It can't be a chemical change. I didn't have any new chemicals up here. All right, so let's do one. Let's do a little demonstration. Now what I have here is a little bit of water, and I put a tiny bit of salt in there. Okay, now the reason I did that is because if I took a 9-volt battery like this one, if I put a wire there, like a paper clip, and touch these, it would get incredibly hot. It'd get very, very hot because the electricity would go through that circuit, and it would make the wire really hot. Did you know that? Have you ever done anything like that? Okay. If you were going camping and you were afraid your matches might get wet or something, you could do something like this. You could take a 9-volt battery and some steel wool. Now, I asked the other class, some of them have never heard of steel wool. Have you heard of steel wool? Some people buy it and it has soap in it, and they call them SOS pads or Brillo pads. Have you ever done that? We had to clean a metal pan. That's steel wool. You can go to a hardware store and buy steel wool that has no soap in it. It's just steel wool. And it looks like really, really thin wires that look like hair, like curly hair. So let's say you took some steel wool with you and a new 9-volt battery. And you're going camping. Oh, we got to make a fire. You can get some dry leaves and sticks, put a little bit of that steel wool underneath there, Take your 9-volt battery and just touch it. If you touch it, electricity will go through all those wires and make them very, very hot, and it'll catch those leaves and things on fire. Have you ever done anything like that? Have you ever touched this with a steel wool? Okay, you'll see sparks and all kinds of things flying out of there because the electricity is flowing through those really tiny wires. So what I'm going to do is put this in here, and then what I believe is going to happen, and I used this yesterday, so I think it's still good. I think it's still good for the day. When I put that in there, we should see the electricity flowing through the salt water, and it's going to be so much electricity, it's going to split the water into oxygen and hydrogen gas. Okay, let's try it. Now, another thing I'm going to do, let me see if I can get that started. Ready? Got to be careful here. This is the difficult, this is the dangerous part right here. Oh! Just kidding. You'll never get shocked by a battery in water. A lot of people talk about electricity. All right, see it? Okay. So anyway, you're not going to get shocked by a battery being put in water. All right. Uh-oh. See if if this guy still has some juice left in him. Oh, yeah. All right. All right, can you see bubbles? See a lot of bubbles giving off? Yes or no? They're small, aren't they? Now, because I had a little bit of corrosion from there yesterday, you're also seeing some of that. I want to do something else that interesting is, how do you know that the bubbles on one electrode, one terminal, are not the same as the other? I'm going to put this in there and see what happens. This is an indicator. It's called phenolphthalein. You've never heard of this one yet. But it might be able to tell me if something's happening at one end that's not happening at the other. Let's see if I can. Okay, that's kind of a mess. I had yesterday's battery, but what you can, let me see if I can get this out of the way. Okay, maybe I'll be able to see it here better. I think that corrosion on that battery is making it kind of a mess, isn't it? Kind of messy. I'll go over here. All right. Anyway, there's so many bubbles being produced. Some of the tiny, tiny bubbles are joining together to make big bubbles, looks like. All right. Well, that's a cheaper way to do electrolysis of water. All right. So, again, one more time. If you have a compound and you have a mixture, a lot of people think they'll say something like, well, water is a mixture of oxygen and hydrogen. That's not true. They are chemically bound together, aren't they? So if you want to separate a compound into its pieces, you have to have a chemical change. A chemical change has to happen. But if I have something that's simply there and they're mixed, it's a mixture, I don't have to use any chemistry to separate them. All right, my next demonstration is one where I'm going to ask you, as I do it, say, what kind of changes do you think are occurring? And say, are they physical or chemical? And then I think you'll like this one too. So let me, excuse me. I'll tell you what I need to do. Let's see. Who wants to be, anybody want to be a camera person? you want, all I need you to do is take this iPad and just kind of take a picture as you do it. Anybody do that? You do that for me? Okay. Now I don't switch it. Right now you have to face it like this, okay? And so here, you take this. Now I need another volunteer. Somebody who's willing to not be too skittish with fire. Anybody about that? Zach, you want to help me? Okay, so here's what I'm going to do. Turn these off. We're over here, so that, I'm gonna bring this part here. All right, you put these on. All right. So what I'm gonna do is, and again, anything you see at home, let's see, don't send her away. How about, how about, anything I do in here, do not do anything at home without your parents' permission. Does that make sense? So this is actually a very dangerous experiment, and if you were to do it without your parents' permission, you actually could get hurt. Did we get that? All right. So what we're gonna do, I'm gonna take some alcohol. This happens to be called methanol. It's just a type of alcohol. This is not the kind of alcohol that humans drink or anything like that. This would actually kill me if I were to drink this. But you can buy it at a hardware store. Now what I'm gonna do is, your job, Zach, is to know how to light this. You pull back on that, like that. And now, when I ask you to light this, it's very important. You might have to peel it down a little bit, but make sure you never, never, never put your hand right over here. Don't ever do something like that, because it's tremendously hot, all right? All right, so let's do the first one. Put some of this in here. Keep this out of the way. All right, now right now I have liquid alcohol. Everybody see that? Liquid. Now what do you think I'm doing right now? What am I doing to the liquid alcohol? I'm really spreading it out, aren't I? What does that do? What does it do when you spread it out? What else might happen to it? What else might happen to alcohol if you spread it out? What if I take some water and spread it out on the table? What does it do? It evaporates, that's right. So what do you think is happening to some of the alcohol right now? It's changed to a vapor, isn't it? Now, so what kind of change is that? It changes from a liquid to a gas. What kind of change is that? Is it chemical or physical? It's physical, because I didn't change it. It didn't change chemical, right? It's vaporized alcohol. The next thing I'm doing is something else was in this container before I started. It was air. And I'm mixing the vaporized alcohol is now mixing with air. And that's going to make for a thing that's pretty good. You need fuel, air, and fire to make a combustion reaction. So now, everything I so far is physical. Are you ready? All right, so get your picture right here. There you go. All right. All right, what do you think? We can do it again.
Oh my gosh.
Now, in that case, what kind of change do you think that was? What do you think? It was. And that was a chemical reaction, wasn't it? Matter of fact, one of the products of a chemical reaction called combustion is water. And there's actually water sitting here right now. Now, I have you pass this around. Don't dump it out. But I want you to notice something else. Not only did a chemical change take place, it also gave off heat. It was called exothermic. It was an exothermic reaction. Can you feel it? All right, we'll do it again. And this time, let's see. Why don't we try it a little differently? Why don't we try it with some rubbing alcohol, which is a different kind of alcohol. All right, ready? We're almost ready. Now I'm using rubbing alcohol this time, and I have one of these bigger drinking containers. There we go. I'm spreading it out. That's a physical change. And I want the vaporized alcohol to also mix with air. All right, here we go. One more. 30 more seconds. Mix, 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 mix. All right, here we go. Ready? Okay. All right, what do you think? Anyway, if you were to do this home, you can get different results. I've had sometimes where it goes boom, 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 boom. It makes a pretty loud noise. It all depends. It's all different. Every time it's a little bit different. I appreciate you doing that. Thank you for doing that.
Mm-hmm.
All right, what we're going to do now, the rest of the period, is you're going to work on the practice test, and then I'm going to walk around and help you with that. So I'm going to stop the video.